So let's implement STP protection now on all devices, and let's start it from root card itself. Fine. So here we are having again 4 switches and interface is, let me configure trunking in between switch 1 and switch 2, 21 and 22. Switch port mode dynamic desirable. Fine. So now show interface is trunk. Trunking must be there, right? And I think some of the interfaces are still shut down here on switch 1. Show run interface fast Ethernet 1/0/19. Not here actually. Might be they are shut down on switch 3. Show run interface fast Ethernet 0/19. Let me check it out. What's this? All switches are connected, but trunking is not there on 19 and 20. Show run interface fast Ethernet 1/0/19. I think yes, now trunking will come up. Done? Oh, still it's not coming up. Access port. It's working as access port. Let's try to bounce these interfaces because output is not as expected. So in that case, you can also bounce your interfaces in unable to perform due to VTP domain mismatch. Now you see, you came to know about the problem. So that is why trunking is not forming in between these two switches dynamically due to VTP domain mismatch, right? So now what can we do? Let's configure VTP domain first. Let's say VTP domain is CCIE. Domain is what? VTP domain is CCIE, and here also on switch for VTP domain is CCIE. Alright. So this time now it must form trunking dynamically. So interface is trunk with all other switches. Fine. Now trunking have been configured in between switch 1 and switch 3. That's fine. After configuring trunking, now what I want, that switch 1 must be configured as a root bridge in this switched network now, right? So what will I do actually? I'll configure spanning tree VLAN 1 to 4094 and priority, let's say I have configured 4096. Let's say that I have configured its priority as 4096, and now you know very well that this switch 1 will become root bridge in this switched network, right? So now you can see show spanning tree VLAN 1. So of course this switch 1 must be root bridge. For VLAN 2 also it must be root. There is no VLAN actually existing here on this switch, as you can check it out here. VLAN 2 is not present in its database, right? So what can we do? VLAN 1 2, we can create 10 VLANs here. So now we will come to know that okay, for all VLANs of course switch 1 will be root bridge, is not it? Show spanning tree VLAN 1, or for VLAN 2, or for VLAN 3, whatever is VLAN. For all VLANs, switch 1 have been configured as a root bridge. After configuring this switch 1 as a root bridge for all VLANs, now what I want, that if any other switch announce itself as a root bridge, then of course root guard must take place, right? So here we are going to configure root guard first of all, and then after I will go for loop guard, right? So first of all, let's implement root guard. So as I said earlier on, that root guard must be configured only on all DP trunk ports, right? So this time you can see that show spanning tree here for VLAN 1, even you can see it for VLAN 1 only, right? So now you can see that for VLAN 1 all of them are DP here on switch 1. So interface range fast Ethernet 1 by 0 by 19 to 24. I'll say spanning tree guard root, and remember that this feature cannot be enabled per VLAN. Now it have enabled, it has enabled for all VLANs. You cannot specify your VLANs for this feature. So this time you can see show spanning tree here VLAN 1. Here it will not show you that whether this root guard is enabled or not enabled, right? But you can do one thing here. You can run this command show spanning tree interface fast Ethernet 1 by 0 by 19 and then detail. In this output it will show you that root guard is enabled on this interface on this port, right? So in this way you can enable this root guard here, and then you can also move on other switches as well, because as I said that on all switches whoever is having DP trunk port, you will always enable this root guard. So again show spanning tree, how many DPs are there? There is no DP actually, all are no DPs. Now let's move on switch 3 show spanning tree. You know very well that except 19 and 20 all others are working as DP. So interface range fast Ethernet 0 by 21 to 24, and I will say spanning tree port fast, sorry, I'll say spanning tree guard root. Then I will move on switch 4, and here also do show spanning tree. I will see that how many DPs are available here. So how many DPs are there? 2. Interface range fast Ethernet 0 by 19 to 20, and here I will say spanning tree guard root. After enabling this root guard, now let's do one thing, because as you know that switch 2 was not having any DP and its all interfaces were working as a non-DP. So what can we do? We can configure its bridge priority as 0 now, is not it? So once we will configure its bridge priority as 0, then this switch will start to announce itself as a root bridge, and if this switch starts to announce itself as a root bridge, then it will start to originate BPDU messages, right? So of course, because it is having all interfaces and non-DP, so in front of all these interfaces it is having DP, so all other switches will put their interfaces into root inconsistent state. Are you getting my point? See, my diagram is something like this. This is switch 1, switch 3, and this is what? Switch 4. Switch 1 is configured as a root bridge. So all interfaces of root bridge are DP. And because we knew that this is RP here on switch 2 and it was in blocking state, blocking, it means it was DP, it was also DP, it was also DP, it was also DP, and it was RP, and it was in blocking state. And in between switch 3 and switch 4 it was something like this. It was DP, and here it was in blocking state. So this is your existing infra. Now because you have enabled root guard on all interfaces only on DP trunk ports, so because you have already enabled root guard on all DP trunk ports here, everywhere, right? Here, and here. Now if you configure this switch 2 as a root bridge, if this switch starts to announce itself as a root bridge, it will start to generate BPD messages in the direction of switch 1, switch 3 as well as switch 4. It will send BPD in the direction of switch 1. It will also send BPD in the direction of switch 3. It will also transmit BPDs in the direction of switch 4. And in all directions upstream interfaces are DP. Is not it? So now switch 1 is going to put these DPs into root inconsistent state. In same manner, switch 3 will also put these interfaces into root inconsistent state. In same manner, switch 4 will also put these interfaces into root inconsistent state. Let's prove it. And they will put these interfaces into root inconsistent state for that VLAN only, for which you have configured this switch 2 as a root bridge. Any problem? So let's do it on switch 2 now first of all, and here I'll configure this switch 2 as a root bridge for VLAN 1 only. So I'll say spanning tree VLAN 1 priority is what? 0. Once I'll configure this command, now you will see that switch 2 will start to announce itself as a root bridge for VLAN 1. I'll not configure this switch as a root bridge for other VLANs, right? I just configure this switch as a root bridge for VLAN 1 only. Show VLAN brief. As you can see here that VLANs must be present here from VLAN 1 to 10. So all 10 VLANs are existing here on this switch, right? So is there any problem till now? So let's move on other switches now. Let's check it out. I mean, let's see output on switch 1, switch 3 as well as switch 4. So on switch 1, 21 and 22 must move into 21 and 22 because switch 1 is connected with switch 2 with using 21 and 22. And one more thing I would like to show you here, that it have put these interfaces into root inconsistent state for only VLAN 1. Let me show you. So spanning tree VLAN 1. So for VLAN 1, of course, 21 and 22 both of them are in root inconsistent state, whereas for VLAN 2 you will see that 21 and 22 there is no problem. Is there? So that's the difference in between inconsistent and error disabled state. If your interface moves into error disabled state, then it will move into error disabled state for all VLANs. But if it is in inconsistent, of course, if it is in inconsistent state, then it will move into inconsistent state for a specific VLAN only. That's the difference in between inconsistent state and error disabled. What? No. Ultimately, it have been blocked. See, for VLAN 1. Yeah, for other VLANs, of course, it will allow data, but only for VLAN 1, it will not allow. If you talk about VLAN 1, it will not allow even traffic as well, because finally it have moved into blocking state. They have been blocked. I mean, now this switch have blocked traffic of VLAN 1. Fine. But traffic of other VLANs will still be allowed through these interfaces. Fine. In same manner, if you move on switch 3, on switch 3 also you will see only 23 and 24. You see. But again, if you check it for VLAN 1, sorry, VLAN 2, there will not be any change. And now if you move on switch 4, so spanning tree VLAN 1. Of course, 19 and 20 will be in root inconsistent state, but only for VLAN 1, not for VLAN 2. However, you can create VLAN 1, 2, show spanning tree VLAN 2. Let me show you. No problem at all. See. So I hope that now you have understood the uses of root guard. So in this way you can implement this root guard. But remember, it does not provide you 100% security, because at least switch 4 have become now root bridge for VLAN 1, right? And in case, let's say that okay, because you configure this switch 2 as a root for VLAN 1, but let's assume that by mistakenly you configured switch 3 as a root for VLAN 1. Now it will become root bridge for VLAN 1, and here because it was non DP, right? So you didn't enable root guard here on switch 2. So for switch 2 also, this switch 3 will become root bridge, even for switch 4 as well. But for switch 1 still it will not be a root bridge. Fine. But if you configure this switch 3 as a root bridge for VLAN 1, then it will become root bridge for switch 2, for switch 4 as well, automatically. Because here you can see at the end of switch 3 you are having already DP, right? And at the end of switch 2 they are non-DPs. At the end of switch 4 also they are non-DPs. And because here they are non-DPs, so on non-DPs you didn't enable root guard. So this time this root guard is not going to protect your switch network from this kind of problem, from this kind of failure. So of course switch 3 will become root bridge for any VLAN, for that VLAN for which you have configured it as a root bridge, right? For switch 2 as well as for switch 4. Any problem? So it does not provide you 100% security, remember. But yeah, of course, at least it can protect your root bridge. Like at least for let's say that switch 1 is working as a root bridge, so it will always remain as root bridge. There will not be any fact on it after enabling root guard.
For that you always use like lowest MAC address to protect.
What lowest MAC address?
On switches and priority like we use 0. Lowest MAC address we use 2.
Can you change base MAC address? Then how can you say that okay you will always use lowest MAC address for root bridge configuration?
Just need to protect like for this kind of.
It's not possible. It's not possible. You cannot say might be that you have bought a brand new switch with higher hardware configuration, you want to configure that switch as a root bridge. How will it be possible to have lowest MAC address among all? Yeah. So it's not going to be possible. Fine. So I hope that now you have understood all these things. But remember, you must not enable this feature on that interface which is working as DP as well as non-DP. In case of load balancing, you will never configure this feature. Never ever. Next is what? Loop guard. Let's talk about loop guard now. So this is switch 1. Let's do one thing. This time I'll be having very small diagram of switch 1 and switch 2 only. Fine. Switch 1 is working as a root bridge, so it will be DP. This is 21 and let's say this is 22, so it will be also DP, and this is going to be RP and it will be in blocking state. Now you are having some users behind switch 1 and also you are having some users behind. Now as I said that due to accidental loss of BPDU, due to sudden loss of BPDU, there can be a problem in your switched network. Like for an example, previously switch 1 was transmitting BPDUs towards RP, but now accidentally it have stopped to transmit BPDUs in the direction of switch 2. So this RP on switch 2 will stop to receive BPDUs coming from switch 1. So after 20 seconds it will lost its RP state, and after 20 seconds it will put this interface into listening, and finally it will become RP and will move into, and if it is not receiving BPD here, so it will become DP. Now both ends will become DP and they will move into forwarding state, and that will cause, that can cause a bridging loop. Let me show you. Here I'll be having R1 0 by 0 is connected to switch 1 0 by 1. Then here I'll be having R2 0 by 2 will be connecting with switch 2 0 by 2. Here on R1 I will be allocating IP address 12.1.1, and here on R2 I will allocate its IP address 12.1.2. Any problem? Now I'm gonna to show you that how can a bridging loop occur. Even STP will be running on your switches, on both switches, right? You will not disable, you are not going to disable a instance of STP for any VLAN, but still there can be a bridging loop. So to prevent your switch network from those type of problems, I'll be using loop guard. So let's start it now. So I'm gonna to do one thing here. I'll move back again on switch 2, and one more thing I wanted to show you in root guard. Like after enabling root guard, if you're, let's say that due to any problem your switch have put your interfaces into root inconsistent state, once your problem will get resolved, your switches will put your interfaces into forwarding state dynamically. You are not required to do anything. You are not required to perform anything on switches. You will come to know that these interfaces like 21 and 22 will move into normal state dynamically. It's not like at a disabled state that once your switch port have moved, see, it have unblocked your interface for VLAN 1. In same manner, switch 3 will also give you this message, and switch 4 will also give you this message, because now switch 2 has stopped to announce itself as a root bridge. Fine. Then after it, what I'm gonna to perform here, interface range fast Ethernet on switch 1. I'm gonna to shut down all other interfaces except 21 and 22. Shut down all these interfaces. After shutting down all these interfaces, like 21 and 22 are still there, right? It means switch 1 is still connected with 22. So interface range fast Ethernet 1 by 0 by 21 to 22, and I'm gonna to disable that feature, spanning tree guard root. Sorry, say no. My God. Fine, so I have removed this feature now, and you can see switch 1 is still working as a root bridge for VLAN 1. It's not it. It is working as a root bridge for VLAN 1. You can see here. And on switch 2, so spanning tree VLAN 1. Let me show you that it is okay. Here on switch 2 also I have to shut down all other interfaces, right? Interface range fast Ethernet 1 by 0 by 19 to 20, and then fast Ethernet 1 by 0 by 23 to 24 for better understanding actually, right? Otherwise I could have performed all these practicals without shutting down all these interfaces as well. But for better understanding, it is really important for us to understand this concept. And now you are having this diagram, a small diagram, and all of you can easily understand this diagram, right? So let's move again back on switch 2. So spanning tree VLAN 1, let me show you that for VLAN 1 still it is having 21 as a root port and 22 is configured as a alternate port. Now if it stops to receive BPD here on root port, after 20 seconds, after doing wait for 20 seconds, it will put this alternate, this blocking port into listening state, and finally it will be elected as new RP, and it will move into forwarding state. Fine, so let's do it. Now the question is that how can we perform this task so that the switch 2 will stop to receive BPDs on its 21? We can enable BPD filter on switch 1, right? Like if I configure BPD filter here on switch 1's 21, then it will stop to send. It will stop to sending BPDU messages, right? I'm gonna to prove it now, and I will also tell you, I will also prove your thing as well. That is correct. That is correct according to the question, right? As per question, as per your scenario, that answer is correct. But here, I'm gonna to show you that it will stop to send BPDU messages now, right? So now I'm gonna to move on switch 1 now once again, right? And let me show you that interface fast Ethernet 1 by 0 by 21, and then I will say spanning tree BPDU filter what enable. Just after enabling BPD filter on this interface of switch 1, switch 2 will stop to receive BPD here on its RP, and it will wait for 20 seconds. Like you can move on switch 2 and you can still check its RP for VLAN 1, still it will be 21. And now you can say debug spanning tree events. So spanning tree VLAN 1, so of course it is 20C, 22 is in listening state, and 21 it have put it in forwarding state as a DP. If it is DP, it means it is transmitting BPDUs back to switch 1, but if switch 1 is receiving BPDUs, of course it will receive BPD, is not it? I got my point. And if switch 1 is receiving BPD, according to you, according to your understanding, now BPD filter should have been disabled on this interface, is not it? But it will not. According to question, that is correct answer. I will explain that situation with you, right? But this time it's not gonna to do that, right? It's not gonna to disable this spanning this BPD filter on this interface now after receiving BPDU message. So here on switch 1, now you can see that BPD filter is still enabled, and here already it was like DP, and still it will remain as DP, you see. And on switch 2, as you can see here, that shows spanning tree VLAN 1. Let me show you that 21 is also DP. So on both ends, in this segment, both ends have become DP. And now what is it saying? Map flapping. And now what can you do? You can move on R1. This is R1, right? On R1 I'm going to allocate IP address to .1.1, and now I'm moving on R2, and on R2 on its FA0 by 1, I will allocate 12.1.2. Now your switches will take some time to put your interfaces into forwarding state, but this time again MAC flapping have started, right? And if MAC flapping is occurring for any MAC address, it means your switches will not be able to forward data for that MAC address. Fine. So now let me show you that from R1 you cannot communicate. Not only it will not affect only communication. It will see now you cannot run any single command on your router.
Why?
Due to loop only. Due to loop only, you cannot do anything now. You can't stop anything. You can't run anything on router. So this time you can see that there is a what? This is not overload actually. This is due to auto sensing of bridging loop.
What if we connect a computer to the instead of
Computers cannot identify these looping conditions, but routers can identify. So there will not be any effect on computers. Computers will still be communicating to each other if switch allows to transmit their data. Fine. So this time you see that MAC flapping have started and now there is a bridging loop. So to prevent this, now how can you avoid this bridging loop? By disabling BPDU filter on switch 1's 21. So let's move again back on switch 1's 21 interface FA0 by 21 and let's disable this feature now. And to disable it, you cannot negate this command. You have to say disable. So once you will disable it, you will see that on switch 2, once again its 21 will become root port, you see, and 22 will again move back into blocking state. And now from R1 you can run all commands and also you can ping 12.1.2. There will not be any problem. Fine. Okay. So it has proved that there can be a bridging loop in your network due to sudden loss of BPDUs. So to prevent your network from bridging loops due to sudden loss of BPDUs, what can we implement? Loop guard. But remember that loop guard will always be enabled only on non-DPs. Fine. So this time on switch 1 you do not have any non-DP, right? So on switch 1 you do not have any non-DP interface for VLAN 1. But if we move on switch 2, so spanning tree VLAN 1. Let me show you that 21 and 22 both of them are non-DP. Interface range fast Ethernet 1 by 0 by 21 to 22, and now I'm gonna to enable loop guard, spanning tree guard loop. You understand? And this time I have enabled loop guard here. So remember that loop guard will be enabled only on non-DP end. So after enabling loop guard, as I described in previous class also, that after enabling loop guard, if you do not receive any BPDU, then it will put that interface into loop inconsistent state. So now if it stops to receive BPDUs on 21, will it make this interface as DP now? No, it will directly put this interface into loop inconsistent state, and traffic will not be allowed of that VLAN for which it have moved into inconsistent state. So this time you can see that this 21, this time it is still working as root port here on switch 2. But now if you move back on switch 1 and if you enable that feature once again, BPDU filter, so interface fast Ethernet 1 by 0 by 21, and now enable this BPDU filter feature once again, and then after you will see that again switch 2 will stop to receive BPDUs on its 21 on its root port, right? So now you can see show spanning tree VLAN 1. Let me show you for VLAN 1. So this time because it have stopped to receive BPDU messages on 21, and after enabling loop guard, if it does not receive BPDU on any interface where you have enabled loop guard, then it will directly put that interface into loop inconsistent state. As now you can see that it have put this interface into loop inconsistent state for VLAN 1 only. As you can see, loop inconsistent state, and now this interface is what? In blocking state for VLAN 1 only. But if you see it for VLAN 2, of course there will not be any effect for. Okay,
I think it's
I enabled BPD filter for all VLANs, right? That is why it have taken effect for all VLANs this time, right? Because BPD filter have been applied for all VLANs. Have you understood it now?
Yes.
So in this way your loop guard will work. Okay, so there will not be any loop now, because if you move on R1 and if you try to communicate with 12.1.2 and repeat is 1000, still it will be communicating with. See, there is no problem at all. Is there? That's it. Fine, guys. So in this way you can enable loop guard. So there will not be any loop now after enabling loop guard on all non-DPs. Fine. So that's all about loop guard. Now let's talk about BPD guard and BPDU filter.
What is this MAC flapping? It occurs
MAC
only
flapping
when-
means if your switch learns a same MAC address on its two different interfaces. That's called MAC flapping. If switch learns same MAC address on its two different interfaces, it means MAC flapping, and MAC flapping will occur due to loop only, bridging loop only.
सर इसके अंदर भी कोई जो अगर मेरा एक पोर्ट आरपीटी है वीएनसी और डीपीजी हम लोग ये enable ही
So I hope that now you have understood the uses of root guard as well as loop guard. So finally, let's talk about BPD guard and BPDU filter. Fine. Now you understand that what is the meaning by BPD guard and what is the meaning by BPDU filter. You know very well that what is the meaning of all these things, right? Now you have two different methods to enable BPD guard and BPDU filter. Fine. One is like interface range on all access ports 1 to 10. Let's say all these 10 interfaces are access ports. So you will always enable in these two features, BPD guard and BPD filter, only on access ports. So let's assume that all these 10 interfaces are access ports. So you will say spanning tree BPDU guard enable to enable BPD guard, right? And if you want to enable BPDU filter, then the command will be spanning tree BPDU filter enable. And now BPDU have enabled on this interface, and this is the hardcore command. This is not a kind of dynamic command. If you have enabled BPDU filter in this way, it means it will never transmit BPDUs out from this interface in any case, in any situation. And also if it receives any BPDU on this interface, on these interfaces, then it is not gonna to process them. So this is one method by which you can enable BPD guard and BPDU filter. You can move under interface mode and then you can enable this feature. Fine. But now what will happen in case if anyone connects switch onto one of these interfaces, it will move into either a disabled state, and if BPDU filter is there, then of course they will not be able to exchange their BPDU messages with each other. Is not it? Switch 2 is not gonna to exchange BPDU with that switch which you have connected to any one of these interfaces. Is not it? That's true, right? Now in your question, according to your question, now I'm coming on another point as well. Like for an here, this is that how can you enable BPD guard and BPDU filter under interface mode. And if you have enabled BPD guard or BPDU filter under interface, it means it will always work. This feature will always work for these interfaces. But to enable these two features, we are also having one global command. Like one is spanning tree port fast default. Like you have enabled port fast feature now globally. Have you understood it?
Yes.
That how to enable port fast feature globally. And you must remember that this port fast will enabled only on access ports automatically. Now how will it be possible for a switch to identify that whether this interface is access port or trunk port?
If it carries multiple layers,
No, I'm just talking about a switch port. In perspective of switch port, that how will it be possible for a switch to understand that this switch is on this switch port fast would be enabled, and on this switch port fast would not be enabled. It will take this decision based on access port and trunk port. So how will it be possible for it to identify all those things?
If BPDUs are received.
Exactly. See, remember on trunk port it will definitely receive BPDU.
messages.
On access port, it will definitely not receive BPDUs in any case. So if your end hosts and stations are connected to these ports, then they will never transmit BPDU messages. Are you getting my point? And then after, because if it does not receive any BPDU, then it will enable this port first feature, and it will start to show you these interfaces as a edge port, because it is not receiving BPDUs on these interfaces. Once it will start to receive BPDU on these interfaces, then again it will lost its it will, of course, it will remove this port first feature from these interfaces, because it will think that it is not access port, it is a trunk port. Have you understood it? That is why try to perform this practical as well by yourself, right? Like take two switches. Now, of course, but let's say that you have taken switch 1 and switch 2, and you know very well 21 and 22 must be configured as a trunk port, right? After configuring these two interfaces, just shut down them. And because they will be in dynamic desirable mode, right? So DTP will take some time to negotiate that whether they will be access port or trunk port. But whenever a port will come up, it will come up as access port, right? It will come up as a access port. So whenever you will say no shutdown, because port first, and remember that you must just enable this global port first feature on both switches, right? After enabling this port first feature globally on both switches, then after shut down your trunk ports and then again say no shutdown. Once you will say no shutdown, it will think, switches will think that these are access ports, and due to port first feature, it will directly put all these two interfaces directly into forwarding state. But once they will receive BPDU, because whenever ports will come up, then switches will also start to generate BPDU messages, is not it? Switch 1 will send BPDU towards switch 2, switch 2 will also send BPDU to switch 1, because both of them will say that we are root bridge, is not it? So once they will receive BPDU messages, then it will immediately come to know that okay, it's port first feature must not be enabled on this interface, right? And again, port first will be removed from these interfaces, and it will directly move back into listening state again, listening, and then they will go through listening, learning, and then finally they will come into forwarding state. Fine. Now I'm telling you another thing. Let's say you have enabled this port first feature globally on a switch. What does it mean? That if you are not receiving BPDU on any interface, till that port first feature will remain enabled. But once you will start to receive BPDU messages, then after port first feature will be removed from that interface. Now, if you talk about BPDU guard and BPDU filter, we can also enable BPDU guard and BPDU filter with using, globally as well, with using this command: spanning tree port first BPDU guard default. And we can also enable this command, with using this command as well: port first BPDU filter. Understood? Any problem? Now, what does it mean? What is the meaning of these commands? This command means wherever port first feature will enabled.
On access port fast, and
Let me tell you. Wherever port first feature will enabled, whether it is a access port or trunk port, doesn't matter. I'm not talking about access port or trunk port this time, right? I'm just talking about all those switch ports where port first is enabled. If you are having, if your switch is having some interfaces where port first is enabled, on those interfaces BPDU guard and BPDU filter will get enabled automatically. The meaning of this command is this actually, that wherever port first will be enabled, then BPDU guard and BPDU filter will also get enabled. Now, if you let's say that you have enabled BPDU filter, right, globally with using this spanning tree port first BPDU filter default, right, and also you have enabled this port first feature globally, right? So now, if you receives a BPDU on any interface, on any access port, port first will be removed from that interface immediately. And if port first has removed from that interface, means that automatically BPDU filter will also be removed. Is not it? So have you understood it now? So don't take it in wrong way. Now I hope that you have understood that question's meaning. Fine. So in this, these are the meanings of all these commands. So now remember that BPD guard, if you enable BPD guard or BPD filter globally, then remember these two features will get enabled only on those interfaces, only for those switch ports where port fast feature is enabled. If port fast feature is not there, then definitely BPD guard and BPD filter will not be enabled.
Only one if you are available.
What?
BPD guard.
At same time, of course, any one of course, and BPD filter will always get preferred over BPD guard. But if port fast is not there, then none of them will be enabled. Fine. And to see your configuration again, show spanning tree summary. Port fast default is by default. BPD guard is by default. Filter is also by default. Understood? Now next is UDLD. UDLD was introduced by Cisco for fiber optical interfaces only. Remember, UDLD was launched by Cisco for, it is a Cisco proprietary protocol. Remember, this UDLD is a Cisco proprietary feature. You cannot enable this UDLD feature on any other vendor specific device, right? And this was this was introduced by Cisco basically for fiber optical interfaces only. Like what happens in what can happen in fiber optical interfaces, like this is switch 1 and this is switch 2. In fiber optics, actually you have two things on a single interface. One is RX, so on another end it will be
TX.
and if it is here RX, then here it will be
TX.
and this is single interface, right? One interface. So let's say that switch 1 is working as a root bridge, you understand? So it will be, and here it will be. Behind switch 1 you are having some lane users. Behind switch 2 also you are having some lane users. Now, because RP will always be received BPDUs here, right? So let's say that there is no problem on switch 1's TX and there is no problem on switch 2's RX, but problem has occurred here. So it will remain as root bridge, it will remain as DP, it will remain as RP, but the thing is, and also the traffic set transmitted by the lane users of switch 1 can be can be received by switch 2, but switch 2 cannot transmit data in the direction of switch 1. What does it mean? That your lane users will not be able to communicate with each other behind switch 1 and switch 2. Of course, all users which are behind switch 1 and switch 2 will not be able to communicate with each other this time. And you will check, okay, is there any problem related to STP? No, it is working DP, it is RP. It means it is there is no problem at all. Everything is fine. Even if I have taught you all these things now, right? But in future, if in live network you find this kind of problem, I don't think so that you will be able to find it. You will never think about it because everything is fine, DP, RP, but it's only they are not communicating. The only major concern is that they are not communicating, and if they are not communicating, it means everything is down. But it will not show you anything that okay, it is down or something like that. It will never show you. So how will it be possible for you to identify these types of problems? For that purpose, we are having UDLD. Even in this case, loop guard can also not work. Let's say that you have enabled loop guard, but still it will keep on to receive BPDUs because there is no problem in its RX. So loop guard cannot help you out in this kind of problem. So for that purpose, now you must be having UDLD. You must enable UDLD on all those switches where you are using these fiber optical interfaces. These fiber optical.
UDLT used only for fiber optical?
No, I'm not saying that only for fiber optical, but Actually, it was launched by Cisco for fiber opticals, but you can also enable it for Ethernet. But however, it is not necessary to enable for Ethernet technology, because in Ethernet, out from 8 pins, if any one of the pin goes down, then entire link will go down. Line protocol will go down automatically. But in case of fiber optical, if anyone, either TX or RX goes down, it will never show you that line protocol is down. Fine. So now if we talk about UDLD, unidirectional link detection, because now previously this interface was bidirectional. Switch 1 was transmitting data towards, in the direction of switch 2, and switch 2 was also transmitting data in the direction of switch 1. But this time, because switch 1 switch 1 can transmit data in the direction of switch 2, but switch 2 cannot transmit data in the direction of switch 1. So now this interface have become unidirectional. So to detect unidirectional links, we are having this UDLD, unidirectional link detection. So whenever you are planning to implement UDLD on your switches, remember that UDLD can be implemented into two modes. One, normal, and another one is what? Aggressive. In normal mode, if it finds that okay, this interface, this link have become unidirectional, so it will simply generate a log message. It will not perform anything else. But in case of aggressive mode, if you configure UDLD in aggressive mode, then if it found any interface as unidirectional link, then it will put that interface into error disabled state. Understood or not? So that's the only difference in between normal and aggressive mode. In normal mode, it will simply generate only and only log message, whereas in aggressive mode, it will put your interface into error disabled state just after detecting UDLD, unidirectional, just after UDLD, unidirectional link detection. So if UDLD detects any link as unidirectional, then it will directly put it into error disabled state if you have configured UDLD in aggressive mode. One more thing, in UDLD normal mode, its timer is I think 7 seconds, and in case of aggressive it is 15 seconds. This UDLD have two types of messages, UDLD request and UDLD response. So UDLD request will always be generated by UDLD periodically. If you have configured UDLD in normal mode, it will send UDLD request is in every 5 seconds, in every 7 seconds. Whereas in aggressive mode, UDLD will transmit UDLD request messages in every 15 seconds. See, if switch 1 have transmit any UDLD request, then switch 2 have to respond with UDLD response. If switch 1 do not get UDLD response back from neighbor switch, it means link have become unidirectional. It means that your UDLD request was not delivered on neighbor switch, or might be it was delivered but now neighbor switch is not able to transmit me UDLD response. Finally, whatever the problem, whether we are not able to transmit or we are not able to receive, whatever the problem, your link will become unidirectional. And just after detecting that your link have become now unidirectional, now it will be depending on your mode, your configured mode, and accordingly it will perform. In normal, it will simply generate a log message. In aggressive, to put your interface into error disabled state. Now, question is that how to enable UDLD, right? So if you want to enable UDLD globally, then you just need to say UDLD enable for normal mode. Then say UDLD. From here, it is something like CDP enable. CDP run, not enable, CDP run. Like you have enabled this UDLD globally now. And then after, you have to move on interfaces and you have to enable it, right? Once again, interface range fast Ethernet 1/0/21 to 22. You have to say UDLD port for normal mode. In same manner, you have to move on switch to interface range fast Ethernet 1/0/21 to 22 and UDLD port. Then after, let's move back again on switch 1 and say show UDLD fast Ethernet 1/0/21. Let me show you. What is that? State is what? Bidirectional. So if it becomes unidirectional, then it can generate a log message. And message interval is what? 7 seconds in case of normal mode. Is not it? Hello? This is normal mode. Now if you want to configure aggressive mode, then the command will be UDLD aggressive globally, and then under interface you will say UDLD port aggressive. Then you will move on switch 2. Here also globally, first of all you will say UDLD aggressive, then go to interface range fast Ethernet 0/21 to 22, and then you will say UDLD UDLD port aggressive. Show UDLD fast Ethernet 1/0/21. Check it out. Now its message interval have become 15 seconds and mode is aggressive and state is bidirectional. Any problem?
Sir, what is the use of fingerprint testing for Ethernet code? Because you are saying like if there is any.
So you are saying that they must modify their iOS coding if they are having fiber optical ports or if they are using Ethernet ports. I'm saying, that's what I'm asking to you. Will you develop any software that, okay, if it is using Ethernet, then don't use this command. Do not allow users to use this command. And if you are using these interfaces like fiber optical, then only allow your users, allow administrator to enable this command. How is it possible?
This is not useful for Ethernet.
That's what I'm saying. And in case let's say that there is no physical damage, might be due to any internal mechanism, your port is not able to transmit data, because finally in Ethernet also there is one pair for TX and one pair is for RS. So again there can be a problem, is not it? So in that case, of course, UDLD can also work for Ethernet ports as well. Any problem? So tell me, if you are having any problem related to STP protection, please let me know. Otherwise, we can proceed with RSTP now. So,
Can we activate port first and run ports?
on
And run ports.
it will not take place, but it can be.
Why is that so?
What?
Is the effect? I've seen that happening, like port fast enable and run ports. But what's the effect of enabling port fast and run ports? I'm not sure about that. Like, why do you do that? I've seen that in networks,
In live networks, port fast on trunk ports.
but I didn't come to know why that.
That's what I'm saying. If you enable port fast feature on trunk ports, it doesn't mean that port fast has been enabled on those interfaces. It won't take place. Let me show you. Interface range fast Ethernet 1/0/21 to 22. I know that you have seen running configuration only. Spanning tree, port fast. Spanning tree, port fast. See, I have enabled it, right? Show run interface fast Ethernet 1/0/21. Let me show you. Port fast is enabled, but these are trunk ports. There will not be any impact of this port fast feature on these trunk ports. What have they done actually? They took entire range of interfaces and they enabled it with using a single command, because they know very well that the uses of this, the effect of this port fast, this command will not be on trunk ports. That's why. Even you can also enable one command is there by which you can forcefully enable this port fast feature on trunk ports as well, and that command is spanning tree, port fast, and then after you have trunk. This command can force your trunk ports to accept this port fast feature. Fine, but I don't think so that this command is there.
I think one of these commands, like if if we do not have a topology where there are redundant links, so we want a trunk port to come into like forwarding state immediately. So does this make that happen?
Yeah, of course, in that case you can. If you do not have any redundant link, and it is not possible to do not have redundant link in any network. Fine, so now you can see that it have moved into error disable state. It have enabled, it have moved into error disable state. Because, yeah, actually what happened, that I enabled global BPD guard on those interfaces where port fast is enabled. Port fast was enabled now on this interface, and BPD guard got enabled. Then after it received a BPDU, and then it have put this interface into error disabled state. Show interfaces status error disabled. Fine. So in this way you can use all these STP protection. Let's start our STP now. So you know very well, you understand very well that why do we required to implement our STP, because in STP when after using port fast feature, this uplink fast and backbone fast and everything, right, still convergence time was 30 seconds, which is too much for any production network, right? That is too much. So to reduce that convergence time, actually they launched finally RSTP and rapid spanning tree. And again I'm gonna to tell you that we do not actually implement RSTP, we are going to implement rapid PVST. This one on Cisco switches, because it will create instances of STP for each VLAN. Clear? Now RSTP of course have fast convergence rather than STP, and in RSTP you are not required to enable either uplink fast or backbone fast, and it doesn't mean that it is having built-in uplink fast and backbone fast. Actually it does not require to enable uplink fast and backbone fast, because it have its own internal mechanism by which it is having fast convergence. Fine. In RSTP you will find in books that its maximum timer will become 6 seconds, is not it? And but what I think that the maximum convergence time taken by RSTP will be 2 seconds in all conditions. The maximum time will always be 2 seconds. Within 2 seconds RSTP, changes in RSTP will converge. RSTP is gonna to converge quickly. Now you must understand that what is the background process of RSTP, that how does it converge quickly actually. And one more thing, by default port fast feature is not enabled in RSTP, and it is compulsory for us, it is mandatory for us to enable port fast feature. If you do not enable port fast feature in RSTP, then it will be better for you to enable STP only. Yes. There will not be any advantage of enabling RSTP, of implementing RSTP in your switched network. So it is really compulsory to use port fast feature along with RSTP. It's mandatory actually. Now I will also prove all these things, that why is it necessary for us to enable port fast feature along with RSTP. Why is it mandatory actually? I'll be discussing all these things with all of you. Fine. After going through all these things, let's talk about some technical part of RSTP now. One more thing, it converges quickly because here in RSTP there is no condition like only root bridge will be generating BPDU messages. Now non-root bridges can also generate BPDU messages, and you know why is it necessary? Because in RSTP we do not have two different types of BPDU messages. Here we are having only one BPDU message. Inside that BPDU only we are having TCN flag. That is why here it is mandatory for all switches to generate BPDU messages if there is any change. In case if there is no change, then of course root bridge will keep on to generate BPD messages, and all other switches will simply replicate those BPDU throughout the network. But if there is any change, then it can immediately start to generate BPDU messages. Have you understood it? Fine. Next thing is in RSTP is that in RSTP, if you understand three things, like RSTP convergence process, that's the only thing that you need to understand actually. Convergence process. Firstly, this sends
proposal.
PER or PR proposal. Yeah, PROPO
SAS.
proposal. Right? Proposal. Second,
Synchronization
synchronization.
and agreement.
And finally, agreement. These three things are there: proposal, synchronization, and agreement. If you understand the meaning by all these three terminologies here in RSTP, it means you understand RSTP. Because whole process of RSTP will be depending only on these three terminologies: proposal, synchronization, and agreement. Let me tell you that how does it really work. Let's say this is switch 1. Whenever both switches will bring up, both of them will start to announce themselves as a root bridge. So it will become DP, DP, and they will send proposal to each other. First of all, they will send proposal to each other. So switch 1 is gonna to transmit proposal in the direction of switch 2, and switch 2 will transmit proposal in the direction of switch 1. So both of them will become DP, because switch can transmit proposal out from DP only. So now switch 1 will send proposal to switch 2. Switch 2 will give its proposal to switch 1. And in proposal messages actually, or in proposal, they are having their BPDUs actually. In proposal, they are having BPDUs. So if we are saying that switch 1 have given its proposal to switch 2 and switch 2 have given its proposal to switch 1, it means they have exchanged their BPDUs. They have exchanged BPDUs with each other. And if they have exchanged BPDUs with each other, it means any one of them will receive superior BPDU. Is not it? Either switch 1 or switch 2. Any one of them will definitely receive superior BPDU. So let's say that its MAC address is A and its MAC address is B. So now, if switch 2 receives a BPDU, it will say that okay, I have received superior BPDU, it means I am not a root bridge. So it will immediately stop to send proposal. It will immediately stop to send proposal out from this interface, and just after receiving superior BPDU, it will perform synchronization, and also it will elect RP. During synchronization, it will also elect RP. So because this time it is having only one interface where it is receiving receiving BPDUs, right, and which is 0 by 1. So it will configure, it will elect it as a RP. And during synchronization, you know very well that it will put all other interfaces into discarding state. And you must understand RSTP states as well. If you talk about the RSTP states, then you know very well that how many RSTP states are there. One is discarding, and second one is what? Learning, and finally forwarding. So they have directly cut 15 seconds, is not it? Like they are having only learning state, and by default your forward delay timer is 15 seconds in RSTP as well. So they have directly cut 15 seconds. But remember, discarding state will also take like 15 seconds. So they have not cut any single second. But still we are saying that RSTP converts quickly. I'm gonna to prove that actually. Remember, now during synchronization, switch will put its all interfaces into discarding state to prevent its switched network from possible loops. Fine. So this time if it is having some interfaces here, so it will put all of them into discarding state. And then because it have performed synchronization now, see, so these states are there. I've discussed with you that here in our STP we are having only these three states, but it doesn't mean that we have directly cut 15 seconds, right? I'll let you know that what will happen actually. See, whenever switch 2 will put, and remember synchronization will be performed that switch only which will receive superior BPDU only. So this time because switch 2 have received the superior BPDU, so of course switch 2 is going to perform synchronization. And in synchronization it will put all interfaces into discarding state. Fine. And at same time, as I said, that it have elected its RP. So whenever a switch will elect its RP, it will also prepare a agreement. It will create an agreement. I mean a switch which will elect RP, it will prepare a agreement and will transmit it out from RP. Will transmit this agreement out from RP that I am RP and you should be DP. That I am RP and you should be DP. So because switch 2 have already elected it as a RP and also have transmit a agreement in the direction of switch 1. So now an interface from which you have transmit agreement and an interface where you receives agreement, both of them will directly move into forwarding state. So this time because switch 2 have transmit this agreement out from this interface, right, and switch 1 have received it here, so it will directly move into forwarding state without moving into learning and discarding state. That is why our STP converts quickly, because now switch 1 have ensured that okay I'm DP, and switch 2 have also ensured that this is RP, and RP and DP must be in forwarding state. So why should they wait for 15 or 30 seconds? Because because they have already came to know that okay we are DP and RP, so of course they must move directly into forwarding state without going through this discarding and learning and all, right? But let's say there was a PC, switch 2 performed synchronization. During synchronization it have put them into discarding, and now remember that once your switch port have moved into discarding state, in case of our STP as well, it will remain there for in discarding state for 15 seconds, and then after it will move into learning state. Finally it will take approximately 30 seconds, I mean around 30 seconds to move into forwarding state. So what is the advantage? What happened? That's what I'm coming on that point. So now there is no advantage of implementing our STP in between switches, because the link in between switches will come up immediately, but still end users will suffer, and users will not be able to get connectivity, fast connectivity, is not it? It will still take like 30 seconds. So what is the uses of our STP? That's why I said that port fast must be enabled. Remember that if port fast is enabled in our STP, then what will happen, that it will not synchronize access ports. It will not synchronize access ports. It will sync only and only trunk ports then, because port fast will never be enabled on trunk ports. So if it does not sync access ports, it means access ports will not take that much time to move into forwarding state. That is why port fast is mandatory, is compulsory along with RSTP. I'm going to prove all these things in live networks as well, fine? But this time you must remember all these things. Now, this time I took simple diagram. Let's make it bit difficult. Like this is switch 1. Just try to understand in this manner now. And this is what? Switch 2. Let's say its MAC address is A and its MAC address is what? B. And this time you are using here 0 by 1, 0 by 2, and this is, let's say, 0 by 2, and this is what, 0 by 1. Fine. And remember that RP election process and DP election process is same as previously. Lowest cost, designated bridge ID, and finally designated port ID. And the election process of electing route bridge is also same as previously. Fine. So let's assume that the MAC address of switch 1 is A and the MAC address of switch 2 is what? B. Any problem? Now, whenever you will turn on these two switches, both of them will start to announce themselves as a road bridge. So just try to understand now. It will become DP. Here it will also become DP, and it will also become DP. And switch 1 will start to transmit proposal out from 0 by 1 as well as 0 by 2. Switch 2 will also start to transmit proposal out from 0 by 1 as well as 0 by 2. In the direction of switch 1. So switch 1 will transmit proposal in the direction of switch 2 out from both interfaces, both links, and switch 2 will also transmit proposal messages out from both interfaces in the direction of switch 1. Fine. Now any one of the switch will receive superior BPDU. So of course again switch 2 is gonna to receive superior BPDU. And because switch 2 will receive superior BPDU on 0 by 1 as well as on 0 by 2. And remember, let's say that another switch is also connected, which is switch 3 here, and it is connected via 0 by 3 and 0 by 4. So now whenever switch 2 will receive this BPDU coming from switch 1, switch 2 will think that okay, it is a superior BPDU, so it will stop to transmit proposal out from 0 by 1 as well as 0 by 2, and it will perform now RP election as well as synchronization. So during synchronization, it will put these downstream interfaces into discarding state and will elect its RP. So which interface is gonna to be RP, 0 by 2 or 0 by 1? Of course 0 by 2 is gonna to be now RP. And because it have came to know that okay, it have received superior BPD here, but it have also elected RP here, so it will be in discarding state. And now because it have elected this 0 by 2 as RP, so I taught you that a switch which elects RP will also generate an agreement. And this time switch 2 is gonna to generate an agreement and is gonna to transmit it out from RP only. So it will send this agreement out from this interface. So switch 1 is gonna to receive this agreement on 0 by 1 and switch 2 is gonna to transmit this agreement out from 0 by 2. So these two interfaces will directly move into. And once this switch 1 will receive agreement in the response of proposal, then it will also stop to transmit proposal out from this interface. Then it will start to send simply BPDU messages only. Fine. Then second, here because switch 1 have not received anything on 0 by 2, have it received any agreement?
No.
And also it is not receiving now proposal from switch 2, right? So because it is DP, so it have to move into forwarding state. So it have to move through discarding, then learning, and then finally forwarding. So it will take approximately 30 seconds and it will remain in discarding state. So this interface will still take approximately 30 seconds. But as you know that it was already here at the end of switch 2, it was already in blocking. So we are not gonna to use this link to transmit data. So now if it is taking 30 seconds to move into forwarding state, it should not affect our lane users. It's not it, because lane users will be using this link only, and this link have already moved into forwarding state. Have you understood it or not? So in this way our STP will converge. And now at same time, because switch 2 have received a superior BPDU, now switch 2 will also transmit a copy of that superior BPD out from this. It will also send proposal message towards switch 3. Switch 3 will also send proposal towards switch 2 as well, and again same process will be followed. But the most important thing that you must remember, that a switch from where it transmits a agreement, and a switch which receives an agreement on any interface, it will directly put those interfaces into forwarding state. And switch can transmit agreement message out from RP only. Have you understood it now? Sure. If you are having any problem, please let me know. Otherwise, I'm just going to implement it now.
When switch 2 receives the proposal, When did it sends the proposal to switch 3 after electing RP or
Not after electing RP, at same time, because if it have been elected, if it has received superior BPD, it is also going to transmit a copy of that proposal message towards its downstream switch as well. Because might be that switch 3 was having like B MAC address, here it was A and it was C. So according to it now, the end of switch 3 must be configured as DP, is not it? So it should not happen. Hello? Will it be like that? Is it possible to have two different root bridges? According to it, of course, switch 1 and switch 3, both of them will be root bridge now for switch 2. Because as compared to switch 2, switch 1 and switch 3 are having best bridge IDs. It is not going to happen. It will never happen. Once switch 2 will receive a superior BPD, it will also transmit a copy of that superior BPD up from these interfaces towards switch 3. So switch 3 will immediately stop to announce itself as a root bridge and also will elect its RP and will send again agreement. So now switch 2 and switch 3 are also going to put this link directly into forwarding state without going through discarding and learning state. Have you understood it now? But remember, port fast must be enabled. Otherwise, your access ports will suffer. Because whenever it will perform synchronization, it will also synchronize your access ports. And again, access ports will take at least 30 seconds because on access ports, it is not going to receive any agreement. On access ports, it is not going to receive any agreement. That is why they will still take 30 seconds, approximately 30 seconds to move into forwarding state. That is why it is mandatory to enable port fast feature, so that after enabling port fast feature, your access ports will become as link. And if your switch performs synchronization, then your synchronization will not affect your as links now. Hello, understood or not? So let's configure it now. So this time, as you know, switch 2 and switch 3 are interconnected. Fine. Let me show you switch 3 and switch 4. This time show CDP neighbors. You can see switch 3 is connected with switch 4 only, right? And switch 3 must be configured as root bridge. Let me show you. Yeah, of course it is configured as a root bridge now. And let me configure our STP here now. Spanning tree. Mode. Rapid PBST. In same manner, on switch 4 also I will say spanning tree mode rapid PBST. And now I'm gonna to show you, to prove you all these things, that first of all both of them will become DP, will send proposal to each other. Any one of the switch will receive superior BPDU, will elect its RP, will send agreement, and all. Fine. Interface range fast Ethernet 1 by 0 by, I think they are interconnected with using 23 and 24. Sorry. 19 and 20. 21, 22. Interface range fast Ethernet 0 by 21 to 22. Shut down. Fine. Now both of them will become root bridge. Hello? Because both switches are not communicating with each other. So of course they will announce themselves as a root bridge now. So let me do one thing, debug spanning tree events. In same manner, on switch 3 also I will say debug spanning tree events. And now on switch 4, interface range fast Ethernet 0 by 21 to say. Now let me show you. I think we are having multiple VLANs.
Yeah.
Don't worry about that. I think we will not be able to see the output here, proper output. Let me do one thing, let me configure only one VLAN in between these two, right? Otherwise it's gonna take so long time. No, one VLAN 1 2. Show VLAN P. There must be only one VLAN now. On switch 3 also, let me say no VLAN 1 2. Oh, BTP mode server. Show VLAN brief. Debug spanning tree. Forget about it. On switch 4 interface range fast Ethernet 0 by 21. Shut down that right. So once again you will see that both of them will be on root base. Like debug spanning tree events on switch 3 as well as on switch 4. Interface range fast Ethernet 0 by 21 to say no. Check it out. That's fine. See, when it was initialized, it became. It will also transmit proposal. However, this time before transmitting proposal, here you can see it transmitted proposal on 21 as well as 22. And then let's say we have moved back on switch 3 now. Fine. When switch 1 came up, what did it say? And transmitted
Proposal
on 21 as well as
22.
at same time 22 it became BP. It means it will also transmit proposal message. It will also transmit, but it also at same time it also received a proposal, right? So it received a superior on 21 as well as on 22. It performed synchronization, right? It performed synchronization, but this time it is not showing me that it is performing synchronization because it does not have any other interface available on this switch except these two interfaces, right? So to whom it will synchronized? That is why I have not given that statement here that okay, it is syncing, it is synchronizing. Is it? Yeah, it is syncing 22, right? Because 21 was
Synchronized.
and it have also synced 21. So first of all it will put these interfaces into discarding state from preventing possible bridging loops. Fine. And at same time it have also elected, and after electing RP, you see transmitting
An agreement.
in the response to a proposal. At same time switch 3 have received and it have directly put those interfaces into forwarding
Straight.
But still it, see now it stopped to transmit proposal out from 21, but still it was keep on to transmit proposal out from 22, because on 22 it didn't receive any agreement in the response of proposal. So it took like approximately, see, 30 seconds to move into forwarding state. And this time I'm gonna show you, right? So let me do one thing, debug once again. Debug is spanning tree events here on switch 3, as well as I will move on switch 4 and I will say debug is spanning tree events. Interface range fast Ethernet 0 by 21 to once again shut down them. After shutting down, you will see that this switch have again become
Root bridge.
switch 3 was already root bridge. It was already root bridge, but this time both of them are announcing themselves as a root bridge. And now if you move back on switch 4 and you say interface range fast Ethernet 0 by 21 to, and then say, I will show you that just after receiving agreement, this DP will move into forwarding state 21, but you see 22 is still in. Let me show you. It will take that same 30 seconds. Even you can see here on switch 4, RP has already moved into forwarding state. And here, now it is in learning state. So whatever I taught you, I have proved here. Is not it? And synchronization is performed by only that switch. See, is it synchronizing? Tell me, this switch 3, because switch 3 didn't receive any superior BPDU. So remember, only that switch will perform synchronization who will receive superior BPDU, who will elect RP and will transmit agreement. Now I said that it is mandatory for us to enable port fast feature. Let me prove it now. And this time I can prove it with using switch 1 and switch 2 only. So I'm already having switch 1 and switch 2 here in this diagram, and switch 1 and switch 2 are interconnected with using 21 and 22. We are having some lane users here, right? So this time, of course, switch 1, let's say that I have configured this switch 1 as a root bridge. It will become root bridge. But initially both of them will become root bridge, right? Will send proposal to each other. Finally, switch 2 will elect this 21 as RP, will send agreement. So we will see that this link will directly move into
Forwarding.
But you will see, because this switch 2 will perform synchronization, so we will see that these access ports will take 30 seconds to move into.
Forwarding.
So let's move on. Switch 2 now. So spanning tree. Oh, loop inconsistent state. Wow. What is happening there? Do show run by begin a spanning tree. Let's remove its all configuration, default configuration especially. No. Yeah, let's disable this, right? First, because we have to prove it that we are required to configure it. Is not it? That's fine. Do show run interface fast Ethernet 1 by 0 by 21. No. Right? And then do show run interface fast Ethernet 1 by 0 by 22. So interface fast Ethernet 1 by 0 by 22. Let me remove. again they'll come up because it was in error disable state, right? That's why I shut down it. Now let's move on switch to default interface range fast Ethernet 1 by 0 by 1 to 24. Show spanning tree. Neighbor switch is root bridge, right? And interface range fast Ethernet 1 by 0 by 19 to 20, and then 1 by 0 by 22, sorry 23 to 24. Shut down. So only switch 1 and switch 2 are interconnected now, right? After interconnecting switch 1 and switch 2 together, you see show spanning tree VLAN 1. So of course it's 21 must be RP. Is not it? And also we are having some access ports 2, 4, 5. Remember 2, 4, 5. And now I'm going to shut down 21 and 22. Interface range fast Ethernet 1 by 0 by 21 to 22. Let's shut down that. So now this switch will also start to announce itself as a root bridge. Let me show you. This bridge is the root. And now let me do one more thing here. Debug spanning tree events. On switch 1 also I will say debug spanning tree events. And let me show you on switch 1 show spanning tree. For VLAN 1 it is also working as a, and see access ports are already in forwarding state on switch 1 and on switch 2 as well. See on switch 1 and on switch 2, on both switches access ports are already in forwarding state. And because all access ports are in forwarding state, and now as I said that switch 1 is, of course switch 1 will be elected as a root bridge, so switch 2 has to perform synchronization. So on switch 2 your access ports will still take 30 seconds. Say no shutdown. You see, we'll come up, we'll send proposal. Oh my god. Wait. We didn't configure mode. So spanning tree mode is what?
Rapid PVST.
Rapid PVST. In same manner, I will move on switch to spanning tree mode, rapid PVST. Fine, show spanning tree, access ports. This is root bridge. To take some time, see. However, our STP is running, is not it, but still you can see that access ports are still taking 30 seconds to move into forwarding state. On switch 2 also, it will be saying that I am root bridge, and you see access ports are already in forwarding state. On switch 1 also, access ports will move forwarding state. Just to wait for a moment. Fine, that's okay till now. Debug spanning tree events. On switch 2 also, debug spanning tree, and then interface range fast Ethernet 1 by 0 by 21 to 22, and then say spanning tree, sorry, no shutdown. So once you will say no shutdown, both of them will send proposal to each other. See, and let me show you now. So spanning tree, RP have already moved into, but still access ports. And synchronization was performed by switch 2 only, not by switch 1, because on switch 1 if you see, you will come to know that okay, access ports are still in forwarding state, and here access ports are still in
learn.
so it is really mandatory to enable
Port fast.
and now I'm gonna to enable port fast feature here. Spanning tree port fast default. In same manner I will also enable spanning tree port fast. So spanning tree, it will start to show you these interfaces as a edge interfaces. On switch 2 also, so spanning tree edge. Any problem? And then after, again I'm gonna to disable interface range fast Ethernet 1 by 0 by 21 to 22. Shut down that. So spanning tree. This time it is not gonna to put them in discarding state. Have it? No. In same manner on switch 1, so spanning tree. Fine. All right. Then after once again say debug spanning tree events. On switch 2 also debug spanning tree events. Interface range fast Ethernet 1 by 0 by 21 to 22, and then say no no shutdown. Just after saying no shutdown command here, show spanning tree. You see, this time your access ports are already in, and it didn't synchronized actually. See, it's synced only 21 and 22. It didn't sync access ports, edge ports actually. Have you understood it? That it is really mandatory to enable port fast feature along with RST. Fine. After going through all these topics, now my question is to all of you here in our STP, because it have feature same as uplink fast, right? Because if its RP goes down, then alternate will directly move into forwarding state. Let me show you. Let's say debug spanning tree events, and now do one thing, interface faster than 0 by 21. Say shutdown. You will see that 22 will immediately move. And here, if your 21 comes back up again, it will directly move again in forwarding state and become RP. There is no root delay timer. See? Now, that's fine. That okay, it will do that. It will do that. My question is to all of you now. In uplink fast, we were having some mechanism to update neighbor switches MAC table. Are you getting my point? In uplink fast, we were having a mechanism to update neighbor switches MAC table. Because we were having that update rate and all. Do you remember that after enabling uplink fast, it was transmitting dummy frames at rate of 150 packet per second, right?
Yeah.
So let's say that you are having this diagram in our STP now. 1, 1, 2, 2, 1 and 2. A, B, C. Root bridge, DP, DP. And this is what? RP, RP, DP block in RSTP, right? And here you are having a host, and this time you are running RSTP. This is 0 by 3. And here also you are having a host. This is also 0 by 3. Its MAC address is D and its MAC address is what? E. So the MAC table of switch 2 will be just after establishing communication between these two hosts, right? Because traffic will always go through via switch 1 between these two hosts.
Yes.
So MAC table of switch 2 will be that 0 on 0 by 3 it have learned D, on 0 by 1 it have learned E. On switch 1 on 0 by 1 it will learn D, on 0 by 2 it will learn E. On switch 3 on 0 by 1 it will learn D, on 0 by 3 it will learn E. Now, because our STP is running, in case if you have this interface, just assume that it have gone down. It will define it as RP and directly put into forwarding state. How would it be possible to update the MAC table of switch 2 immediately? However, it will generate TCN. But again, after generating TCN, switches can set their MAC addresses in time equal to forward delay time, which is by default 15 seconds. So again, in our STP, there must not be any communication between these two lane users till next 15 seconds. Is not it? And because there is no update rate, something like uplink fast, that it will keep on to send dummy frames at rate of 150 packets per second. There is nothing like that. So how will it be possible? And it's not possible. Like if you are using RSTP, will it be really possible for lane users to wait for 15 seconds? Of course no, due to MAC table only. Of course no. So RSTP is also having its own internal mechanism by which it can also update its own MAC table immediately. Remember, in RSTP there is a simple rule, very simple rule, that whenever in RSTP there is a very simple rule that whenever a switch will receive TCN BPDU on any interface, whenever a switch will receive a TCN BPDU on any interface, it will flush. Let's say that switch 2 have received, because it is going to receive TCN BPDU over here, right? So whenever switch 2 will receive this TCN BPDU here, it will flush all MAC addresses from its MAC table, all MAC addresses from its MAC table learned on all other interfaces, on all interfaces except that interface where it received TCN BPDU. Means that if switch 2 receives TCN BPDU on 0 by 2, it will remove all those MAC addresses from its MAC table immediately, which learned on 0 by 1 or on 0 by 3 on all other interfaces except,
Receiving interface.
of course, it is not gonna to remove all those MAC addresses from its MAC table which learnt on its 0 by 2. It will not remove them. But apart from this interface, except this interface, it will remove all other interfaces. It will remove all MAC addresses learnt on all interfaces. But there's a big problem due to it only. Of course, it will converge its MAC table immediately, but due to this problem, due to this MAC table updation, due to this type of MAC table updation, there will be too much unknown unicast flooding. There will be too much unknown unicast flooding, because you see that switch 2 will immediately remove these two MAC addresses from their MAC table. There is a very simple rule that whenever a switch will receive TCN BPDU, it will flush all MAC entries from its MAC table except those MAC addresses which learned on that interface where it received the TCN BPDU. So due to this reason, switches will perform unknown unicast flooding. So yeah, in RSTP that is the problem, that switches have to perform unknown unicast flooding if there is any change in your network. That is the disadvantage of RSTP, but of course it is having fast convergence.
Convergence.
Have you understood it now?
Yes, sir.
For sure. Hey guys,
Yes, sir.
the procedure used by, the process used by RSTP to converge, and like as I said that it will also require to update their MAC tables as well, switches MAC table. So I hope that you have understood that how RSTP is gonna to update its MAC table immediately. So if you are having any question, please let me know, otherwise I can wind up this class now. What? Tell me, do you have any question related to this RSTP now? Everything is clear now? Fine. So